Hi everyone, welcome to my YouTube channel. In this video, we are going to discuss on relationship between F and R. So we are going to derive the formula for F and R. So F is the focal length and R is the radius of curvature. So before that, we draw a ray diagram for a curved mirror. So let's say this is the curved mirror, concave mirror, and this is the principal axis. So a ray parallel and close to the principal axis is incident at the point A. So the pink ray here. And when it is incident at the mirror surface, it is reflected towards the focal point. Okay, for the parallel ray, the ray is reflected to the focal point. And another ray drawn below, also a parallel ray, and reflected towards the focal point. And this is the normal to the curved mirror. So the line here is from the center of the curved mirror. Imagine the curved mirror form a circle, big circle or sphere. So the C here is the center of that sphere. So let's say the angle here A, the angle here B. So the angle here theta. So A is equals to theta because this is alternate angle, and B is also theta because using the reflection rule. So the angle, incident angle equals to the reflection angle. Okay, so the length FP is called focal length, and the P to C is called radius of the curvature. Okay, so we are going to prove that the formula is F equals to R per 2. So radius of curvature divided by 2, or half of the radius of curvature, is equals to the focal length. Okay, from the diagram just now, this is theta. From the this B also theta because reflection rules, and then this 2 theta is the alternate angle. Okay, from the maths you've learned. Okay, then therefore the triangle CAF here is the isosceles triangle, because the angle, two interior angles here are the same. So the CAF will form a isosceles triangle. Okay, next the exterior angle here, okay, will be theta plus theta, so becomes 2 theta. So we use exterior angle theorem. Okay, theta plus theta, we get 2 theta. And because this is theta, this is 2 theta, so therefore the CF equals to FP. Okay, so the 2 theta here becomes half. Okay, so the length CF equals to FP. So we relate with the focal length and R. So CF is half of R, and then FP is F. So it is proven that the F equals to half R. Okay, this is one method. There is another method to prove the relationship between F and R. We use trigonometric ratio. Okay, so this is the curved mirror, the principal axis P. Okay, the parallel ray. So the reflection ray will point towards the focal length. Okay, this is the normal. So the points comes from the center of the curvature. Okay, the angle here theta. So here theta, here also theta, and here is 2 theta. Okay, then the F to P is focal length, and then the C to P is radius of the curvature. Okay, so the point, let's say we name this point K. So the triangle CK point here is M. Okay, so the parallel ray here is close to the surface. So we can say that M and P here is at the same point, because the parallel ray here is close to the CP. So the triangle here will form a right angle triangle. Okay, the KFP actually equals to KLM, because M and P for the close parallel ray to the CP will make the M and P as if they join together. So we use trigonometric ratio for tangent to theta here. Tangent theta is opposite is km, and the adjacent is fm, which is equals to f. Fm and fp is the same, f, focal length. Then for the bigger triangle KCM also we do the same, the angle here theta. So tangent is opposite per adjacent, opposite is km and the adjacent is r. So remember I said just now M and P is at the same point, so we can equate CM or CP equals to R. Okay, so using this identity, tangent to theta equals to 2 tangent theta per 1 minus tangent squared theta. So we substitute these two into here. So km per f equals to tangent to theta. Km per f equals to tangent to theta. So tangent to theta is 2 tangent theta. So 2 tangent theta is km per r. And then 1 minus tangent squared theta. So tangent theta is km per r squared. Okay, we substitute, we combine the three of the equation here. So we get this. And then because km is close to CP, so therefore the km per r squared is approaching 0. So we can equate this to 0 for a very close parallel ray to the CP. Okay, next, this one is 0, so 1 minus 0 is 1. So the equation above become km per f equals to 2 km per r. Then we can cancel out km. So cross multiply, we get r equals to 2f. So proven that the equation, the relationship between f and r is f equals to half r. Okay, this is the second method to prove the relationship between f and r. Okay, for the convex mirror, also we get the same answer. We get f equals to half r. Okay, look at this ray diagram. This is the parallel ray reflected here, because this is convex mirror. So here theta, here also theta. The angle here is theta, so we use corresponding angles. The rules for angles. Okay, here theta, here also theta. Okay, then reflection rules, so B also theta. And here we use this also theta, because we use intersection here. The angle B theta here is equals to this theta. Refer to the diagram here. D A equals to C, B equals to D. Okay, so when the two lines intersect, two pairs of particularly opposite angles are formed. So they are equals in magnitude. So here theta, here also theta. Okay, so using exterior angle, exterior angle theorem. So the exterior angle here is equals to the sum of the two opposite interior angles. So here means theta plus theta, so becomes 2 theta. So therefore, because this is theta, this is 2 theta, so the two length here, PF equals to CF. PF equals to CF. And therefore, CF is F focal length, and PC here is the radius of curvature. So therefore, it is proven that F equals to half R. So this is for convex mirror. Okay, we try one example. A concave mirror has a radius of curvature of 20 cm. So find its focal length in cm. So the solution is So given here is the radius, so we are going to determine f. So use the equation f equals to half r, and r is 20 cm divided by 2, we get 10 cm. So the focal length for the concave mirror is 10 cm. Okay, so that's all for the video, and thank you for watching.